Hi guys, I'm sorry that video disconnected. So this is going to be part 2. Let's finish up. So now that we've got this solid line graphed and we have the slope and we have the y-intercept, okay, and it's going to be shaded above. So we're going to shade above this. Okay. So now what I'm looking at is I have 4 parts here. I have part A, part B, part C, and part D. I need to shade the part where my 2 arrows, either the red, need to shade where both the red and the black arrows would overlap, okay? So when I look at area D, there is no arrows that point within this section. Okay, no red arrows, no black arrows. So that's not going to be where I'm shading. If I look at area A, the only arrow that points here is this black one. There's no red arrows pointing in that direction. So I wouldn't use that one. In section B, okay, here I have both the red and the black arrows pointing here. So this is actually going to be the section where solutions are possible. Okay. Please remember that solutions can end in the shaded area here. So there can be a solution in here. There can be a solution anywhere on this solid line as long as it's touching that shaded area. And a solution will never be on the dotted line, okay, or the dashed line. All right, now for the second part of the second video, I'm going to switch to a different screen here. So let me go ahead and back out of this. And I want to go to writing a systems of equations. Now, the one that I'm going to be working on is number 7. Okay. So a plane is flying at an altitude of 5,000 feet. It starts descending, going down at a rate of 100 feet per minute. Okay. So feet per minute. Plane B is flying at an altitude of 4,100 feet. It starts ascending, which is going up, at a rate of 50 feet per minute. If the plane starts changing altitude at the same time, how many minutes until they are flying at the same altitude? So we are looking for minutes, and their total is going to be the altitude. Okay, so the x is going to be minutes and the y is going to be the altitude. When we write these 2 equations, we are going to be able to write them in slope-intercept form, which isn't always true, but in this case it is. Okay, so we're going to let x represent the minutes and y represent the height or the altitude. Okay. So for plane A, we need to know its total height when they meet. We don't know it yet. That's what we're trying to find. Okay, that total height, or how high that plane is, and what it's going to equal is the slope. So where is it at? Is it increasing or decreasing? Well, plane A is flying at an altitude of 5,000 feet. Well, that's its starting value, so that's going to be the B, the y-intercept. Okay, so we know that the y-intercept is going to be 5,000. And it's descending, so descending is going to be negative. So it's going to be negative 100. Negative 100 per minute. Okay, so we don't know how many minutes there are. That's what we're trying to figure out as well. So it's going to be positive 5,000 feet because it is above ground. So now when we look at plane B, okay, plane B, we have to find the height of that one. Their height's going to be the same. That's trying to find out where they're going to intersect. Their height, not the planes. Then on this one here, this one is ascending, okay, at 50 feet. So that's positive 50 because it's increasing. We don't know how many minutes before their 2 heights are the same. but we do know that he's currently at a positive altitude of 4,100 feet. Okay, so those are my two equations. When I have those two equations, let me erase this here. So those two equations, what I'm going to do is I'm going to solve them using elimination, because that's what we've been practicing. Okay, when I look at these, I can see that the y's are lined up, the equals, the x's, and the constants. Okay, so I'm going to try to eliminate something. Well, I'm going to go ahead and try to eliminate the y's, because they're both a positive y, so all I need to do is make one of them a negative. So I'm going to take this whole first equation and I'm going to multiply it by -1. So that's going to give me negative y is equal to 100x minus 5,000. My second equation is so y equals 50x plus 4,100. Okay. Now, add those two together. So we get 0 equals 150x minus 900. Okay. Take that negative 900 that's on the right side and move it to the left side. So I have positive 900 is equal to 150x. Divide the left side by 150, and I get x equals 6. Okay, so it's going to take 6 minutes for the plane A and plane B to be at the same altitude. All right, 6 minutes. And that's what they're asking us. Now, if we wanted to find the altitude, we wanted to find the y, what we're going to do is take 6 and substitute it in to either plane A's equation or plane B's equation. In this case, I'm going to go with plane B. Okay, so I'm going to kind of narrow all that off because I'm not using that right now. So plane B is 50 times 6 plus 4,100. Okay, so we get y equals 300 plus 4,100. So the y equals 4,400. Okay. So our answer is in 6 minutes. Both planes will be at 4,400 feet altitude. Or we'll both be at an altitude of 4,400 feet. Okay? All right, excuse me. Now I'm going to look at number 8. Number 8. A mom gives her small child either dimes or quarters for helping with odd jobs around the house. At the end of the day, the child has 9 coins with the total value of $1.20. How many were dimes and how many were nickels or quarters? So we're going to let X represent the number of dimes and Y represent the number of quarters. Okay. So in this one, we have to have a number equation. So the number equation is going to, when we're looking for the number of coins that he has, So we don't know how many dimes he has, we don't know how many quarters he has, but we know we're going to add them together to get the total of 9 coins. Okay. Now the value of the coins. Well, each dime is 10 cents. Each quarter is 25 cents. Oops, 0.10x, 0.25y. And that is going to equal $1.20. Okay. So now what we're going to do is take these two equations and solve them using elimination. All right, so I'm going to go ahead and eliminate the x's just because 0.10 is easier to multiply than 0.25. Okay, so I'm going to multiply that whole top equation by 0.10, but it's going to have to be a negative because I want them to eliminate for the x's. And if I have a 0.10x plus 0.10x, that's just going to give me 0.20x. So I need one to be positive, one to be negative. Okay. So then I will have negative 0.10x minus 10y equals 0.90. Now the second equation I do not need to change at all because I want those x's to eliminate. Okay. This first one should be a negative 0.90 because we were multiplying a positive times a negative. Okay. All right, now we can go ahead and add those two together. The negative 10x, negative 0.10x and the positive 0.10x, they eliminate. So we've got, oops, this should be a positive 0.25. Here, negative 0.10, positive 0.25 gives me 0.15y is equal to negative 0.90 plus 1.20 gives me 0.30. When I divide by 0.15, I get y is equal to 2. So this child had 2 quarters. Okay? 2 quarters. So we know if he had 2 quarters and he had 9 coins, he had to have 7 dimes. So the mom gave her child 7 dimes and 2 quarters. Okay. All right, the rest of this is for you, which is problem number 9. I want you to find out the equations for the hamburgers. And for the fries, I'd like to know the cost of each one. Okay. When you are done with this, you can upload it to Canvas. And I will see you all tomorrow.